So far, we've been generating data tables by running queries. It's also possible, though, to create your own data table in KQL by using hard-coded values. To do so, we'll need to use the data table keyword. After that, in parentheses, we define the layout of our data table. The first column in my data table is going to be called ID. We then have a colon, and then we have the data type for that column. So ID is going to be an int. We have a comma and then define our next column, time generated, as a date time. After that, we've got two more columns, YouTube name and YouTube URL, defined as strings. After our closing parentheses, we want to then define what data to place into our data table. To do so, we'll use our opening square bracket. We then have the first piece of data, which is the number 1, and it's going to go into my ID column, a comma, and then we have our date time to go into the time generated column. Note that I can't just enter 2018-04-01. I actually have to cast that as a date time using the date time function so that it's compatible with the data type of time generated. I then have my strings for the YouTube name and YouTube URL. I then have another comma, which is the marker for the next row of information. I repeat this for each row until I'm done defining the data. I then have a closing square bracket. When I execute this, we can see the data comes back. We can make this much more useful if we combine this with a let statement. Here you can see I have let, and I'm creating a variable to hold my data table called favorite YouTubers. I then have the data table keyword. I'm then defining the output of my data table, but here you can see I'm using a vertical layout instead of the horizontal layout I did a moment ago. KQL itself doesn't really care which way you do it, but using a vertical layout does make it a little easier to read. In addition, if I decide I want to add or remove columns from my data table later, this makes it a little easier to do so. Likewise, I am defining the data using a vertical layout pattern. I have the opening bracket, I have the first column, comma, second column, comma, third column, and then I get to the comma that defines the next row. For readability purposes, I have done indentations with the different commas at the different levels. This is not a requirement of KQL. I want to make that clear. KQL doesn't care where you put the commas. I, however, find it a little easier to read if the commas that separate the columns are indented 2 spaces. The columns that separate the rows are flush left with the opening and closing brackets. That's exactly what I've done here, and I think you'll agree that it makes it much easier to find the start of each row because I can just look for the commas that are in the first column. I then close it out. I have a semicolon. I then take my data table, favorite YouTubers, and I project out just the 2 columns I want. And here we go, a list of data from our data table. Let's actually do something practical with this now. Here I'm going to define a new data table named computers. It's going to have 2 columns, my computer name and friendly name. You can see below I've entered data for 5 rows, Contoso SQL Serve 1, and it's going to have the friendly name of Contoso SQL Server 1. I repeat this for the other rows. I then define a second data set as a query into my perf table. I'm giving the data set the name of perf_info, and I'm just getting data for the last hour, returning the computer time-generated counter name and counter value. After that definition, I fall into my main query. You can see I'm using the computers data set. I'm joining that to the perf_info I created with the let statement. Here I need to use the left and right syntax because the column holding the computer name doesn't have the same name in both tables. The column holding the computer name is called computer name in the data set I defined. In the perf table from Azure, however, the computer name column is stored in a column simply named computer. Well, I combine these together and execute, And now I'm going to get back a listing that has a friendly name for each one of these computer names. So this is a much more practical example of a way you could use a data table within your queries.